Hello friends, welcome back to the YouTube channel. So in this video we'll start with the lab assignment 1 of deep learning of BE information technology, which will be as per SPPU syllabus 2019 pattern. So I hope you have all filled out the exam form with academic bank of credits, that is ABCID. So if not, please fill out the forms because tomorrow is the last date for filling out the exams forms without late fee, and with late fee it's 10 November. So if you have any doubt in filling of this exam form with ABC ID or how to generate that ABC ID, you can mention that in the comment section. Okay, so now we'll start with our first practical lab assignment. So the problem statement for this assignment is study of deep learning packages, that is TensorFlow, Keras, Theano and PyTorch. Document the distinct features and functionality of the packages. So basically this assignment is the study assignment, completely theoretical assignment, no implementation, no coding in this assignment. So you have to ask your subject faculty or the practical faculty that whether this assignment will be there in your final practical examinations or what type of questions can be asked based upon this assignment, because this is the study assignment and you have to just know about the packages or the libraries that you are going to use in the further assignments. Okay, and also let me know in the comment section that from when your practical examinations are scheduled, because it totally depends upon the college and the availability of the external, and depending upon that they can schedule your practical slots. So let me know in the comment section from which dates your practical examinations are there. And second is about the ISR, that is information storage and retrieval. You don't have the practical implementation of the assignments. You just have the Viva based upon the practical concepts that you have used in your practicals or related some theory related to that particular practicals from the syllabus. So that also you can confirm from your college faculties. Okay, so now we'll start with this assignment. So first library, or you can say the first package, is the TensorFlow. So the TensorFlow is an open source library for numerical computation. So we can perform the numerical computations using this TensorFlow library, and this is an open source library. Then it bundles together machine learning and deep learning models and algorithms. So whatever the algorithms or models are there inside machine learning and deep learning, that are grouped together or bundled together by the TensorFlow. Then it uses Python as a convenient front end and runs it efficiently in optimized C++. So it makes use of two languages. First is the Python for the front end and C++ or the optimized C++ for running the programs. Then it allows developers to create a graph of computations to perform. So we can create graphs, and in graphs we know that we have the nodes, and that nodes are connected with the other node with a connection. So each node in the graph represents a mathematical operation. Then it can be addition, subtraction, multiplication, division, simple operations, and each connection represents the data. So whatever the connection between those nodes are there, that represents your actual data. Then this TensorFlow library is developed by the Google, or you can more specifically Google Brain, in the year 2015, and it basically developed for the Google's internal use, but now it's used by the other organizations as well. Then applications of this library, so it is used in text-based applications, image recognitions, voice search or voice recognitions, and many more. For example, in Deepface or Facebook's image recognition systems, TensorFlow is used for image recognition, and also it is used by the Apple Siri for voice recognition. Then it takes an input in the form of an n-dimensional array or a matrix, which are known as tensors. So which flows through a system of several operations and comes out as output, and hence the name is TensorFlow. So what TensorFlow does, it takes an input in the form of n-dimensional array or matrix, and then it passes that input through a system of several operations. After one operation it will perform the other, then after other. Okay, and then it finally comes out as an output. And we can also generate the graphs using this TensorFlow. Then all the computations associated with TensorFlow involves the use of tensors. So whatever computations, then it may be a numerical computations or graph computations, those are associated or involved with the use of tensors. So now what do I mean by this tensors? So the tensor is a vector or a matrix of n dimensions representing types of data. So now these types of data is nothing but the data types. So these data types can be your integer, float. Okay, so this is nothing but a vector or a matrix of n dimensions representing types of data. Then values in a tensor hold identical data types with a known shape. Okay, so now identical data types means what? You can consider an array. So in array you can have, suppose I have taken the integer array. So in that I can have multiple integer values which are stored inside that array and can be accessed using the index. So these are nothing but identical data types. So all the values inside that particular integer array will be of integer data type. Okay, and this shape is the dimensionality of the matrix. So what do I mean by dimensionality of the matrix? So for example, in matrix, if you have considered the two-dimensional matrix, then you will have two dimensions, either a row and column. Okay, you can have the rows and columns. So for example, if I am having 3 into 3 matrix, so there we have 3 rows and 3 columns. So these are nothing but the dimensionality. Then a vector can be a Okay, so the vector, what do I mean by now vector? So one dimensional tensor is known as vector, two dimensional tensor is known as matrix, and zero dimensional tensor is known as scalar. So now if you found this difficult, you can just remember a few of these points. First, TensorFlow is an open source library for numerical computations. Second, it bundles machine learning and deep learning models. Third, it uses Python and C++. Fourth, you can write this also. It allows to create a graph of computations and it is developed by Google. Okay, and also you can have remember 1 to 3 applications because they are simple. So image recognitions, then voice recognitions. Okay, and if you have found this part difficult about this input form of an n-dimensional array, and then ignore this part. Just remember a few points about the theory and applications or features. Okay, now we'll move to the second library, which is Keras. So Keras is a powerful deep learning library that runs on top of other open source machine learning libraries such as TensorFlow and is also open source itself. So Keras itself is an open source library and it runs on other open source machine learning libraries such as TensorFlow. Then it provides a Python interface for ANN or artificial neural networks, and it acts as an interface for the TensorFlow library. So you can say that it acts as an interface for the TensorFlow library. Then third is Keras contains implementations of commonly used neural network building blocks such as layers, objectives, activation functions, optimizers, and a host of tools to make working with image and text data easier to simplify the coding necessary for writing deep neural network code. So if you found this point a bit lengthy, you can just write that Keras contains implementations of commonly used neural network building blocks. And if possible, remember few of them, that is activation functions and optimizers. This can be easily remembered. Then Keras has support for convolution neural networks and recurrent neural networks, and it supports other common utility layers like dropout, batch, normalizations, and pooling. And it is very quick to make a network model. So that's why we use this Keras to build our network model. Okay, so now we'll move to the third library, that is Theano. So we are not using this library currently in our practical assignments, but we'll see if we need this in our further assignments. Okay. So Theano is a Python library that allows you to define, optimize, and evaluate mathematical expressions involving multidimensional arrays efficiently. So whatever the mathematical expressions you have along with the multidimensional arrays, it allows you to define those, then optimize those and to evaluate those expressions. Then it is mainly designed for handling the types of computations required for large neural network algorithms using deep learning. So here you can just remember mainly designed to handle the types of computations. Okay, so just remember this part. Then advantages. So it has basically three advantages. Stability optimization. So in that you can find some unstable expression and use more stable means to evaluate them. So suppose in your mathematical expressions you have some expressions which are unstable. So this theorem can help you to find out those expressions and make them stable. Okay. Then execution speed optimization. So this theorem can make use of your recent GPUs and execute parts of expression in your CPU or GPU, making it much faster than Python. So this theorem, in short, it increases your speed of execution. Okay. And third is symbolic differentiation. So it is automatically creates symbolic graphs for computing gradients. So it is used to create symbolic graphs for computer gradients. So these are the three advantages of this library. Then last library is PyTorch. So PyTorch is also an open source machine learning library which is used for developing and training neural network based deep learning models. So basically it is used for developing and training neural networks. It is primarily developed by Facebook's Artificial Intelligence Research Group. PyTorch, it can be used with Python as well as a C++. And unlike most other popular deep learning frameworks like TensorFlow, which uses static computation graphs, PyTorch uses dynamic computation and which allows greater flexibility in building complex architectures. So here you can remember that PyTorch uses dynamic computations. Then it uses Python core concepts like classes, structures, and conditional loops, and thus it is easier to understand. PyTorch is easier to understand because it just uses the Python basic concepts like classes, structures, and loops, and use of applications or in which fields it is used. So it is used in computer visions or natural language processing, that is NLP, and many more. Okay, so these are the four libraries that we have to learn in this assignment. So you can take out this screenshot if you want. Okay. So yeah, you want, if you want to take screenshot, you can take out the screenshot. Okay, now I'll move to the next library. Okay, you can take out the screenshot of this. Okay, third library. Take out the screenshot of this. Now I'll move to the last library, that is PyTorch. Okay, so take the screenshot of this also if you want. Okay, so that's it for this assignment, and the next assignment will have based upon the, I think, feed forward neural network. We have to implement it. Yes, we have to implement feed forward neural network using Keras and TensorFlow. So that's why we have learned about this first assignment, that what actually this TensorFlow, Keras, and PyTorch libraries are and what actually their applications are. So from next video we'll start with the second assignment of the feed forward neural network. So before that, make sure that you fill out the exam form. You have contact your faculties or practically in charge, and you have asked them about your practical exam schedule. Third, ask about your project submissions as well, because in project stage 1 you have to publish the first paper, research paper. So also if you have any doubt, you can ask your particular guide and get your doubt solved. Okay, so now also if you have any doubts while filling the exam forms with ABC ID, let me know in the comment section. I'll guide you to how to exactly fill out those forms. Okay, so that's it for this video. We'll see in the next video. Thanks for watching.